Hello, we are team segmentation fault, and our team members are.
Hi, I'm Di Hua.
Hi, I'm Zihao Zhou.
I'm Kun Chunhei.
And I'm Qian Yisha. Hi, this is our presentation for our board, and here is the motor. This is the motion sensor, and it is initializing right now. And here is the humidity and temperature sensor, and here's the LED. So as we can see here, the program is initializing now. It has to take 1 minute for all the component to finish initializing. And in our design, each of the component have his own thread to let them run at the same time and control and detect all the information we need. And here we can see all the sensor information and the API information showing on the console. The main system just finished initializing, and the LED start to print out all the critical informations. As we can see, we have the time at the beginning and the seamless temperature and humidity and the local temperature humidity to showing on the LED, and also with the ETO values. And it scroll to the end of it to show all the informations. But right now, since it's already 5 in the morning, so the motor, the irrigator won't work because the ET values are 0. And here we can see how much waters we wasted through the calculation. And here's another refresh for the information and the system. And the functionality are basically all of this.
As you can see, this is the entry of our main program, and it's defined the main system. So in the import library part, it imports the several subcomponents that we defined previously and we present previously, like the sprinkler and the humidity, temperature sensor, and that kind of stuff. And in this class, and we have done the init method, and we initialize each subcomponent. And then this method will be called when we start the main system. And it contains several threads. Like one of them would be like continuously looping to sense the temperature and humidity. And the other one would be like keep getting data from online API from the CIMIS website. And the other one would be like keep refreshing the LCD, and you can see in more details about the code here. And there's also some algorithm here, like updating the hourly average and scrolling the LCD and using one of our class to calculate the local ETO value and that kind of stuff. Yeah, that's basically it.
Hi, this is our test bench for our DHT sensor, and as you can see in this is the main function for this sensor. It will detect the temperature and humidity here, and at this part, this is our test bench. It will keep looping. It will keep in a loop and printing the humidity and temperature. And we'll start the test bench. Okay, it's now reading the data. Now we are putting on a code things on the sensor, and as you can see, the temperature is slowly, yeah, it is very slowly getting down, and the humidity, you can see the humidity came down very fast. Yeah, the temperature is getting lower. And this is it.
Hi, this is our class for the PIR sensor, and we read this class as a thread. So here, at the start, we will start the thread. When we call this function, it will start the thread, and here to terminate the thread. And also, when we detect motion from it, we will run this function, and it will give a signal to the sprinkler to tell it to stop working. And here's the main function that it will loop through and check the signal each time. And here's the test bench. And it is
As you can see, this is the cast for irrigation sprinkler, and it's basically has several member functions like turn on water and turn off water, and you can see that this is my test bench. So it basically would turn on the water, which means turn on the motor and make it run for 10 seconds, and then it will be turned off. So I'm going to run the test bench right now. Alright, that's it.
Okay, this is our file to pull the data from the website, CMS website. And here we just apply for the app key, and here's our app key. And then we use the current datetime. We import this library, and this is the function we initialize all the data for the hour, ETO, temperature, and humidity. Okay, this is how the data should be returned through these functions. Okay, so here is our basic two major functions, and here is extract data. So it will go through a try and accept method, and here we said the timeout should be 10 seconds. And here is the update data. And so we're gonna extract the CMS hourly ETO, humidity and temperature. And here's how we access those data from the report we pull from the website. And here is how we set up our current time. So basically, when we check from the report, we found the index for the time is from 0 to 23. So that's why we you basically use the current time to -2. And then if the current time is at midnight or 1 a.m., we use the day before and plus use the hour plus 22, and this is how we derive the hour when it cannot pull from the last hour, and that's it. Okay, here I'm gonna show you how this module works. Okay, here, so here, because this is our test bench, so it only works for one time, but actually our main program, it will loop forever to check the time. And as you can see here, the hour is 5. When you check the time over here, it's 5 a.m., so it's correct. And this is the value for ETO and the humidity and the temperature. And that's it's basically the same as from the website, so all the information is correct. Okay, so here's the design for our final project, and here's the LCD will show up all the information that you need for the CMIS for the water information. And this is the motion center, and we use the light to shows up the signal when it detects the person. Just walk past it, and the light will turns on. Okay, so this light connect to the motor. So once the motor turns on, the light will turn on. Okay. So first thing first, the screen will show up the time information, and then it will show up the irrigating system information. Based on our design, the irrigating system will start irrigating once per hour at the very beginning of the cycle. So as you can see later on the screen, you will show up a message that says the motor is on. Okay, and okay. Okay, so here is the time, the current time, which is okay, 10 p.m. And then after that, you will show up the irrigating system information. And based on our algorithm, the calculation we used, we will calculate how much water you will use for irrigating. So here the lights turns on. Okay, so and then we interrupt the system. Okay, so you see the light turns on because we simulate the scene when someone passes it. And then after that, you will also detect again where you will continue watering if there's no one in front of it. So the motor turns on, the light turns on, which is very expected. Okay, so we calculate the time for the motor to operating. And then after that, we retrieve the data from the CMIS website, and it shows up the information of temperature, humidity, and ET value. So here we retrieve the data for temperature, which is 71.9. And the second row shows up the local temperature. And we also set up the screen to have the function of scrolling information. So you scroll to the left, and you will hold the screen for 3 seconds for displaying the value. Okay. And you also show up the how much water you used or you saved. Okay, so as you can see here, you start the next cycle, and this is our overview for our design. Okay, thank you.